contract from NASA's Jet Propulsion Laboratory in Pasadena, California. After a 560-mile trip from Orbital's facility in Arizona, the satellite arrived at Vandenberg on April 30th. It then was transported to the Astrotech Payload Processing Facility. Inside the clean room, technicians and engineers began uncrating the OCO-2 spacecraft. The 985-pound satellite then was placed on a test fixture to begin weeks of intense pre-launch checkouts to ensure all of its complex systems are working properly. During December of last year, a convoy of trucks began delivering the solid rocket motors to Vandenberg for the United Launch Alliance Delta II rocket that will boost the satellite to orbit. In late March, the Delta's first stage booster arrived at NASA Hangar 836. On March 28th, the Delta II first stage booster was transported to Space Launch Complex 2 and raised to the vertical position and hoisted into the mobile service tower. 2 weeks later, the 3 solid rocket motors were attached to the first stage of the booster. The Delta II second stage then was towed to the base of the mobile service tower at Space Launch Complex 2 on April 15th. The instruments and systems on OCO-2 were thoroughly tested at Astrotech's Vandenberg facility, including the all-important solar arrays. While orbiting the Earth, the arrays will capture the sun's energy and generate 813 watts of power for the spacecraft systems. With a primary structure consisting of a 7-foot-long hexagonal column that is 3 feet wide, OCO-2 is about the size of an office desk. Once final checks were complete at the Vandenberg Astrotech facility, the satellite was enclosed in its transportation canister and prepared for the trip to the launch pad to meet up with the Delta II vehicle. By mid-June, OCO-2 was ready to be placed atop the Delta rocket to begin final preparations for liftoff and its 24-month mission. Once in orbit, OCO-2 will study carbon dioxide levels of the Earth's atmosphere from an orbit 438 miles in space, providing scientists with a better idea of carbon dioxide's impact on global climate change.
Off this morning, we're hoping that from one of the optical trackers on Santa Ynez Mountain down towards Santa Barbara that we may see the Delta II rocket coming up through the fog here at Vandenberg, and we'll be following with that same tracker the Delta II as it heads downrange. It'll be going almost directly down the Santa Barbara Channel on a launch azimuth of 196 degrees. And we'll continue south. There'll be some radar contact with it at Point Magoo, north of Los Angeles, a Navy station there. And on past Los Angeles, San Nicolas Island will be providing some telemetry data just below LA. And at that point, about 7 minutes into the flight, the TDRS West tracking and data relay satellite will pick up the vehicle and be supplying data until we get to the Heart of Easthoek tracking station in South Africa, which will be giving a status for the rocket's second stage restart and the spacecraft separation. That'll be at 49 minutes. And in addition to that, we will, after spacecraft separation, the Near-Earth Network Station at Fairbanks, Alaska will be giving us some spacecraft state of health from the 36-foot antenna located near Fairbanks. We're at T-minus 58 minutes, 20 seconds and counting. This is Delta Launch Control.
That will break this reflected light into its component colors.
So you can literally measure the light absorbs and count the number of molecules throughout the atmospheric column from the top to the bottom.
Earth's plants and oceans absorb carbon dioxide and also emit it back into the atmosphere. This give and take is a natural process. But that balance began to shift at the dawn of the Industrial Age. That's when, with the dawn of the industrial age, that's when human activities began to pump more and more carbon dioxide into the atmosphere, an increase of about 40%.
But the amazing thing is that half of that buildup has occurred since 1980. And one
Dioxide into the atmosphere, an increase of about 40%.
But the amazing thing is that half of that buildup has occurred since 1980. And 1/4 of that buildup has happened since 2001. So the rates of buildup of carbon dioxide in our atmosphere, mainly 1/4 of that buildup has happened since 2001. So the rates of buildup of carbon dioxide in our atmosphere, mainly from burning fossil fuels and other human activities, and goes on.
From its vantage point in orbit, OCO-2 will be able to track Earth's atmospheric carbon dioxide around the globe about twice a month through every season for at least 2 years. Although humans have been adding significant amounts of carbon dioxide to the atmosphere over the past 2 centuries, it also appears that the Earth's plants and oceans have been absorbing more than usual. Where this additional carbon dioxide is going is one of the big mysteries scientists hope to solve with OCO-2. As the chlorophyll in plants absorbs sunlight and carbon dioxide to create carbohydrates through photosynthesis, they re-emit small fractions of this energy as fluorescence. The instrument on board OCO-2 will be able to detect this chlorophyll fluorescence, allowing scientists to see where plants are actively growing and whether there's a response in atmospheric CO2.
And the two in combination, carbon dioxide in the atmosphere and an indicator of how effective plants are in taking CO2 out of the atmosphere, it's just an impossibly brilliant combination from a science point of view.
OCO-2 will circle Earth every 99 minutes. As it sweeps from south to north across the sunlit hemisphere, it will pass overhead around 1:30 in the afternoon local time.
After about a 16-day period, the Earth rotates under the satellite such that we're back on exactly the same ground track. We get an opportunity to map out the whole Earth every couple of times a month.
But first, OCO-2 has to get into the right place in Earth orbit. The spacecraft will get its boost into orbit from a Delta II rocket, a reliable vehicle with a workhorse reputation. NASA's Launch Services Program ensures the spacecraft and rocket are ready to fly, working in tandem with rocket provider United Launch Alliance.
The NASA Launch Services Program team has been preparing for the OCO-2 mission for almost 2 years now. Requires a polar orbit. That's an orbit that would cross the north and south poles, covers a tremendous amount of area of the surface of the Earth. And the only way to achieve a polar orbit